And this is my demo for final project. So you can see that here the red line is the goal line and you're trying to get the white line to match. And so if you regenerate it, it's a procedurally generated random red line. And here you can adjust the controls, change the amplitude. I'm gonna guess about maybe that. Change the frequency up a little bit, and then maybe phase shift it. It's starting to look right. And then you can confetti. And then once you do, you can go on to the next round. It adds another layer of complexity. You have two sine waves being added this time, and you can always toggle the screen here for help. Sort of like a little hack. Got the first one done there. And then the second one should be done here. Change the phase up a little bit. There we go. Next round, and you can go all the way to round 5 is the max. So let's take a look at the code. There's just some CSS to align everything. All the buttons for the specific messages. So just importing all our global variables here. I use an array structure to keep store of the wave parameters and the goal wave, which is goal wave is the red, the user is the white one that they're manipulating. So first, in this init function, I just create the environment setup, the scene, the skybox, the materials, and the lights. Nothing too notable here. You know, obviously change the orbital controls and look around. What's just interesting is this create materials, in that it should be a tube material. So here I take in array of points, I create a curve, and then I create a new tube geometry. It's around 1,000 tubular segments for smoothness. And here's just the function update the wave meshes. Based on the user's actions when they change the wave, that'll change both the user and the goal mesh. So it will re-render the scene. And here is the randomization function. So this is what the goal wave is procedurally generated on based on the current rounds. It adds that to what amplitude, frequency, and phase, and then it returns that to the color. We'll get to that later, but and so for example, amplitude is a value 2 to 20, frequency 0.5 to 3.5, and phase is between 0 and 2 pi. And so here you actually see the change enacted. It gets pushed to the amplitude array within the goal wave here. So this goal wave array is actually what holds all the values for the current goal wave. And this is, in essence, the summation. It reflects all the changes in angle on the y-axis based on the amplitude, frequency, and phase. And here are just some special considerations. For example, anything that's phase shifted by 2 pi is the same. And anything with a negative amplitude and phase shifted by pi looks the exact same as another sine wave with no modification. So there do need to be some normalizations there for certain values. And this is the code for updating the UI. That is, and it also truncates it, truncates the real value. It's actually some long decimal value. But that's what's generated here. And as you increase rounds, it just adds to the amplitude, frequency, or phase array within the goal wave object here. And this follows a similar pattern for point creation, but this is for the user wave. And here's just the function, a grouping of functions that I call when I want to update the visuals based on any user changes in the setting parameters here. Another thing here is how we check a wave match. So these are the thresholds. Obviously have to normalize some values, such as amplitude, or normalize the phase, but if amplitude is within a margin of error of 0.7, phase margin of error 0.4, or frequency is 0.3, that should work. And if it is, it's a match. And that's how you see the top banner on top. So just reset so you can see it. Let's see. Let's make a good guess. Amplitude maybe about 11-ish. Frequency, the frequency is high, so the waves appear tight. So maybe I phase shift it a little bit. Separate it a little more. And I hit the help button. So I see the amplitude is a bit higher. Frequency is a bit lower. And phase shift just a little bit more. There we go. As you can see here, it checks if that's a match. And if it is a match, it displays this what I call match message, which is this banner up top here with the button to go to the next round. Click. And here's just some functions for managing the current goal wave. So it just adds the current values after calling generate random wave params. It will add it to the goal wave data structure. And here's how I create controls. I create controls based off of this attribute that I call total harmonics, which is basically the round that you're on. So for each round you're on, it will create a new container, one of these containers, and just append it to this big control container so that each one gets this little box for each additional round that you're in the game. And add some functionality to the buttons as well. Obviously, the next round button increments the current round count. And then it will create in what I call wave params. It'll create a default amplitude, frequency, and phase. So as you can see, once round 2 started, it generates this with some default values. And it updates the controls and the visuals as well. And here's how the harmonic controls work. These controls here, I get the index of which control box is being changed, what attribute is being changed, which one of these 3 types is being changed, and to what value. And I update this wave params data structure. And then I update the wave visuals by calling update wave visuals. And then some other functionality for the buttons, for example. And also, just one last thing, this confetti thing. It comes from, this library that I found on NPM. You can find it here, install it, and then you can call this confetti function with some values. And then, let's see. You did see it earlier, but I just want to demo it again. After you get around cracked it, runs this trigger confetti function and it throws confetti. So yeah, I think that is it for this project. So thank you for watching and goodbye.